Thank you for your interest in our work. Today, I'm going to present FRAMES-VQA, benchmarking fine-tuning robustness across multi-modal shifts in visual question answering. Here's the outline of our presentation. Previous research has found that unconstrained fine-tuning of pre-trained foundation models leads to worse robustness to distribution shifts. For example, in Figure 1, fine-tuning clip on ImageNet improves in-distribution performance but leads to performance degradation on ImageNet variants. Therefore, a series of robust fine-tuning methods are developed to preserve the generalization capability of the pre-trained model during fine-tuning. However, most robust fine-tuning methods are examined under distribution shifts in a single modality, for example, images. We propose a multi-modal fine-tuning robustness benchmark to evaluate models under different kinds of shifts. FRAMES-VQA consists of 10 VQA datasets. VQA-V2 serves as the in-distribution dataset, and 6 near out-of-distribution datasets introduce shifts from VQA-V2 spanning unimodal, multi-modal, and adversarial shifts. Additionally, there are 3 FAR-OOD datasets, which differ entirely from VQA-V2 in image and text sources. We benchmarked several robust fine-tuning methods on FRAMES-VQA, including vanilla fine-tuning, linear probing, which only fine-tunes the linear head, LPFT, which is a two-stage approach that fine-tunes the linear head first, then fine-tunes all layers. TPGM, FTP, SPD are all constraint optimization methods that enforce the model to stay within the distance from the pre-trained models to preserve the robustness from them. We also include WISE-FT, which linearly interpolates pre-trained and vanilla fine-tuned weights to combine the strength from both. We fine-tune on VQA-V2 with PalyGamma 3B and test on OOD datasets using LoRa. We find that vanilla fine-tuning improves zero-shot performance across in-distribution, near, and far OOD. Also, WISE-FT decreases both ID and OOD performance. These trends differ from unimodal settings, where vanilla fine-tuning typically harms OOD performance, and WISE-FT often improves both ID and OOD performance. Nevertheless, several robust fine-tuning methods still offer potential for improvement in the multi-modal setting. For example, SPD achieves the highest performance on ID, near, and overall OOD. FTP underfits ID data but excels on far OOD datasets.
In this section, we quantify covariate shifts across both text and image modalities using feature-based representations from various backbones and fine-tuning methods. For example, to obtain joint representations, we input the last layer embeddings of image and text. To measure distribution shift, we use the Mahalanobis distance, which captures how far a test sample deviates from the training distribution, averaged across all samples. This heat map visualizes the strength of the distribution shifts across 10 test VQA datasets, where VQA-V2 train is our in-distribution. As we move from near to far OOD datasets, all shift increases, and the question and joint modality has increased shifts at much higher rates than the visual one. We hypothesize that far OOD datasets either have more severe textual shifts or that VLMs capture shifts much more significantly in textual representations. We also explore the relationships between unimodal and multimodal shifts by analyzing their direct linear relationships. We find that multimodal shifts are more strongly influenced by question shift rather than image shifts, and that the more robust fine-tuning methods exhibit this lower correlation, implying that robustness may stem from balanced cross-modal interactions. We also want to analyze the relationship between model robustness and the modality and importance metric, which looks at the ratio of attention weights on text over image tokens. Upon this, we find that for OOD samples, text tokens pay increasing attention to the image modality, possibly explained by the significant language drift which we observed previously. Also, we find a massive intermodality attention amongst text, potentially hinting to the lack of image grounding. To summarize our observations in future works, we find that fine-tuning increases the question influence upon multimodal shifts, and therefore more robust methods may need to focus on alleviating direct uni- and multimodal shift correlations. Lastly, from the modality importance analysis, we find that it may be important to further reinforce image grounding whilst promoting intermodality attention. For more details, please check out our paper and code available on GitHub at the link below. Thank you.